Hello everyone, I'm Kaiselin from hikvision. Welcome to our CGSE Video Security Network Basic course. After taking this course, we can become familiar with basic network knowledge, understand the working principle and the technology of switches, understand the technology of IP routing, and know how to design a network. Our course is divided into 4 parts. The first is network basics, and we will introduce some of the concepts and terms of the network. Then we will introduce the working process of the Ethernet switch. In this part, we will focus on the working principles and the function of the switch. After learning the Ethernet switch, we will introduce some routing concepts, and finally, we will introduce how to design the network. In the first chapter, we introduced the network basic, divided into 6 parts, including the introduction of common network devices, typical network structure, reference model, common protocols, IPv4 introduction, and MAC address introduction. Let's look at several devices commonly used in video security networks. First, Ethernet cables and optical fibers. Then network cards and switches. Select an Ethernet cable or an optical fiber. Based on the requirements, the transmission distance of an Ethernet cable cannot exceed 100 meters, while the transmission distance of an optical fiber can exceed 100 meters. The NIC interface type can be PCI, PCIe, or USB. Switches are also one of the commonly used devices, and the working principle of switches will be described in Chapter 2, Ethernet switch. What we need to know about switches is that the backplane bandwidth of switches requires twice the maximum speed of all interfaces. And what is the backplane bandwidth of the switch? It refers to the amount of data that the switch can transfer. It should be twice the sum of the highest rates of all ports on the switch, and this value can be used to show the forwarding performance. Another important parameter of the switch is the port speed. The port speed of the switch determines the performance of the switch. We can log into the web configuration interface of the switch to check the port status. The normal status port color is green. The structure of the campus network is generally divided into 3 layers. They are the access layer, the aggregation layer, and the cron layer. At the access layer, terminals are connected to the access switches, including PCs, IP cameras, and AC devices. Access switches are connected to aggregation switches. Aggregation switches are connected to cron switches or routers. Viral servers are also connected to the aggregation layer or cron layer devices as required. And the cron layer is connected to the internet through the firewall. Now that we know the physical architecture of the network, how exactly does data transfer between devices? Let's look at the OSI reference model of networking and the TCP/IP protocol suite. The OSI model divides the network into 7 layers, and data is encapsulated through each layer, while the TCP/IP protocol suite has only 5 layers, which are the application layer, the transport layer, the network layer, the data link layer, and the physical layer. The data format is different at each layer, and each layer runs different protocols. So let's take a look at what protocols are available at each layer. Before we look at the types of protocols, we need to understand what is the protocol. Data communication is working by the collaboration of software and hardware in the same protocol. In the TCP/IP protocol suite, every layer has different protocols, and these protocols enable communication between hosts across the network. The commonly used protocols at the application layer are Telnet, SMTP, HTTP, HTTPS, and SNMP. TCP and UDP are commonly used at the transport layer. The most commonly used protocol at the network layer is IP, ICMP, ARP, and RARP. The data link layer has Internet Protocol and P2P protocol. The physical layer transmits data through physical cables. We have just seen the HTTP protocol in the application layer. Let's learn how the HTTP protocol works. Its full name is Hypertext Transfer Protocol, which is an application layer protocol for distributed, collaborative, and hypermedia information systems, and is a data communication foundation of the World Wide Web. The working process of HTTP is, first, the web client will enter the URL in the search box, such as the website address. The web client will then use DNS to get the domain name mapping IP address from the web server, and then it will use HTTP to request changes to the web page. The web server uses the URL to find the page file stored locally and return it to the client. After the web client receives the HTTP reply, the browser analyzes and displays the page content in the browser. Another common protocol is HTTPS. HTTPS is a secure HTTP channel which can also be set to a secure version of HTTP, adding an SSL layer to a HTTP protocol. The security foundation of HTTPS is SSL, so the details of encryption requires SSL. The HTTPS workflow is as follows. Another important concept to understand next is IPv4 addresses. The IP protocol assigns each node in the network a globally unique 32-bit IP address. An IP router works as a layer 3 network layer based on the destination IP address and routing information of IP packets. An IP router selects an appropriate path to forward IP packets to the destination node. An IP address, also known as a logical address, is 32 bits long and is generally represented in dotted decimal notation. Dotted decimal is easy to read and write and easy to configure, but communication devices read binary IP addresses, so we need to be familiar with decimal and binary conversion. For example, here we have an IPv4 address 172.16.11.1, and if we convert it to binary, this is shown in the table. The IP address consists of two parts, the network part and the host part. We will use the network mask to distinguish the network part and the host part. The network mask and IP address are used together, where the bit with the value of 1 mapping the network bit in the IP address, and the bit with a value of 0 mapping the host bit in the IP address. IPv4 addresses are classified into 5 types by IANA. The first 8 bits of class A are network part, and the first bit is 0. The first 16 bits of class B are network part, and the first 2 bits are 10. The first 24 bits of class C are network part. The first 3 bits are 110. Then the first 4 bits of class D are 110, but these are multicast addresses, while the first 5 bits of class E are 11110, and the class E is a reserved addresses that is not assigned to sites on the public network. A public address is a unified address assigned by the IANA. This public address is unique in the Internet. IANA is an organization that assigns Internet Assigned Numbers Authority, IANA, responsible for IP address allocation planning and port definition of TCP/UDP public services. In addition to the 5 types of public addresses, there are 3 types of private addresses. These private addresses cannot be used on the public network and are generally used by enterprises or internal organizations. If the devices on the internet need to connect to the internet, NAT technology is required. Understand the public IP address and the private IP address. Let's learn a technology. Its name is NAT, Network Address Translation. The typical application scenario of NAT is as follows. Private addresses are used on the internet, campus, or home, and NAT is deployed on the egress device. For inside-out traffic, the network device uses NAT to translate the source address of the packet into a specific public address. And for inside-out traffic, the destination address of the packet is translated. If we need to configure an IP address for the PC, we can manually configure an IP address for the PC. Enter the IP address, subnet mask, default gateway, and the DNS server addresses. Then we can complete the configuration. Another option is to use the DHCP protocol to allow the PC to obtain an IP address automatically. If we select to obtain an IP address automatically, the DHCP protocol automatically helps the PC obtain an IP address from the configured DHCP address pool. The full name of the DHCP protocol is Dynamic Host Configuration Protocol. It can automatically assign IP addresses to settings. Its working process is as follows. First, the client sends a DHCP Discover broadcast packet to the DHCP server on the current network. The server then sends a DHCP Offer unicast packet that carries the IP address assigned to the client. The client sends a DHCP request broadcast packet to inform the server that it wants to use the IP address. The server sends a DHCP ACK packet to inform the client that the IP address can be used. Now that you know the concepts of an IP address, let's look at what a MAC address is. A MAC address is a 48-bit address, and each NIC has a unique MAC address. A NIC uses a medium access control as its unique identifier. The MAC address of a NIC is unique in the world. A MAC address contains 12 hexadecimal digits, the first 24 digits being OUI and the last 24 digits being EUI. The IEEE is the organization for MAC address assigns, which is responsible for assigning OUI, and vendors themselves assign EUI. Now that the content of the first chapter is over, let's review the content of the first chapter through these topics. First question. What are the layers of the OSI protocol model? The answer is there are 7 layers: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. The second question, what kind of IP address does 130.10.1.1.255.255.0.0 belongs to? The answer is it belongs to class B IP address. Which technology is required to enable a device with a private IP address to access to the public network? The answer is we can use the NAT technology to translate private IP address into public IP address to access to the public network. The last question, MAC addresses are usually represented by 12 hexadecimal numbers, which are divided into 2 parts. AUI assigned by the IEEE and the EUI assigned by the vendor. The second chapter is mainly about the Ethernet switch. The first is introduction of the Ethernet switch, and then we will introduce the working process of the Ethernet switch, the 3 kinds of frame processing behavior of the Ethernet switch, and finally, we will talk about the technology used by the Ethernet switch, such as the VLAN, the link aggregation technology. On the network, the switch is the device closest to the terminal user and is used for terminal access to the campus network. Switches at the access layer are generally layer 2 switches. Layer 2 switches work at the data link layer and forward data frame based on MAC addresses. Okay, let's take a look at how the switch works. First, the host sends data. The switch decapsulates the received data and obtains the information from the data frame header, the active MAC address, and the destination MAC address. After obtaining the source and the destination MAC addresses from the frame header, the switch queries the destination MAC address in the MAC address table maintained by the switch. If the destination address of the frame is found in the MAC address table, the switch forwards the frame from the corresponding port. The switch has 3 behaviors for the received data frame. They are flooding, forwarding, and discarding. Flooding means sending the frame to all the switch interfaces except the interface that received the frame. Forwarding means sending a data frame to a specific interface, and discarding means not transferring a data frame. In addition to understanding the 3 behaviors of switches, we also need to understand the technology commonly used in switches, VLAN. The VLAN technology enables a switch to divide multiple broadcast domains and isolate broadcast frames between different broadcast domains. This technology saves bandwidth and improves the data processing capability of the switch. There are 2 types of switch interfaces. The first one is access interface, which is used to connect with the PC or the terminal device. The access interface can only join into one VLAN. The other one is the trunk interface. The trunk interface can allow multiple interfaces to pass through. These interfaces can be distinguished by the 802.1q tags. The trunk interfaces are used to connect with the different switches. As shown in the figure, different interfaces on the switch are assigned to different VLANs. Port 12 of switch 1, port 345 of switch 2 are assigned to VLAN 3. Port 345 of switch 1, port 12 of switch 2 are divided into VLAN 2. Therefore, broadcast frames sent by host 1 are target VLAN 3 only and transmitted to the devices connected to port 345 of switch 2. The broadcast frames sent by host 2 are target VLAN 2 and sent to the devices connected to port 12 of switch 2. Interfaces belonging to different VLANs are isolated from each other. If we use the website to configure the VLAN, firstly, we need to log into the switch and then click Basic Configuration, VLAN, 802.1q VLAN, and fill in the VLAN ID. Click Basic Configuration, VLAN, and Port Configuration. Select the access port VLAN type and the VLAN ID. Click Basic Configuration, VLAN, Port Configuration. Select the port VLAN type as trunk and set the VLAN ID. After configuring the access interface and trunk interface, all configurations of VLAN technology are completed. Another switch technology we usually use is link aggregation technology. By bundling multiple physical links into one logical link, Ethernet link aggregation, either trunk, can increase link bandwidth without a hardware upgrade. A logical link formed when multiple links are bundled together is called a link aggregation group. Each aggregation group corresponds to a unique logical interface. This logical interface is also called a link aggregation interface or an ether trunk interface. The interface rate, duplex mode, and the VLAN configuration of an Ether trunk must be the same. The configuration step is firstly, click link aggregation, switch configuration, and choose load balance mode. Then select an interface to perform link aggregation. Create a link aggregation group and set the group ID. Complete the VLAN configuration. We can see the aggregation group list has two ports, G1 and G2. Now that we have completed with Ethernet switches, let's review what we have learned with questions. The first question is, what are the three behaviors of Ethernet switches? Through the previous study, we already know that the switch has three behaviors, which are forwarding, flooding, and discarding. The second question, if the ports on the switch are in the same VLAN, what domain do the ports belong to? We need to know all ports on the switch are in the same broadcaster domain. The last question, what technology can be used to increase link bandwidth and realize link backup? We can bundle multiple physical links into one logical link using link aggregation technology. Having learned the first two parts, let's start the third part, IP routing. IP routing mainly introduces this part. The first is a review of IP routing. The second is some parameters. The next is a comment of IP routing. And finally, we will introduce the classification of routes. First, we need to know what is IP routing. We know that layer 2 switches can enable devices to communicate in the same LAN, but in the actual scenario, it is impossible to divide all hosts in the same LAN. If devices in different LANs can communicate with each other, layer 3 devices such as routers and the layer 3 switches are needed to help realize data forwarding between networks. Each router maintains a routing table. The routing entries are stored in the routing table. The routing entries have some important parameters. For example, the destination network indicates the network segment where the destination host resides. Must identify a network segment with the destination host. Outgoing interface, the interface that leaves the router when packets are transferred. Next hop indicates the next hop address used by the router to forward the packets to the destination network segment. If we want to view the routing table on the device, we can use the show IP routing table command. Use this command, we can see that the route entry is maintained by the device. Routers discover routing information in a variety of ways. The router will select the best route to put into the routing table. There are three ways to discover a route. The first is a direct route. The route of the network segment where the direct interface resides is automatically generated by the device. Then there are static routes. Route entries manually configured by the network administrator. Another type of route is called dynamic route. The route learned by router through dynamic routing protocols such as OSPF, ISIS, and BGP. Here are three questions to review what we just learned about routing. The first question, list the three parameters that appear in the routing table. Three parameters are destination, mask, next hop, interface. The second question is, please list our comment if we want to view the routing table. The comment is, show the IP routing table. The last question, which route entry is manually configured by the administrator? So the answer is, static route can be configured manually. The last chapter is about the design of the network. We have understood the basic concept of the network, and to better understand the structure of the network, we will introduce some parameters that need to be considered in the network design. There are some important parameters we need to pay attention to when designing the network. The first is video streaming characters. Video streaming has some main characteristics, such as some abruptness, non-benign, rash advance, sensitivity to loss, and sensitivity to delay. Video stream use RTP, Real-Time Transport Protocol, and UDP protocols. So we need to care about these characteristics. We can also predict the cost through this formula, which should be 20% of the video calibration bandwidth. When designing the network, it is also necessary to pay attention to the critical node bandwidth. Typically, critical nodes receive more traffic, and we need to pay attention to the bandwidth of critical nodes. Several factors may affect the network transmission bandwidth. For example, in topology design, we can design a 2-layer or 3-layer tree network structure or a ring network structure. Different structures have an impact on the network transmission bandwidth. The convergence between the inbound bandwidth and the outbound bandwidth of network traffic also affects the network transmission bandwidth. The selection of different models has a great impact on the network bandwidth. 100 megabits and 10 gigabits capacity of different switches has different network transmission bandwidth. So we need to pay attention to these factors to control the pressure of key nodes. If we need to evaluate the performance of the network, we can consider these aspects. The first is device specifications. We can understand differences between video gross data stream, video bitrate, and switch specifications. The second is the number of connected channels. We can estimate the total bandwidth required based on the number of channels and the single channel stream bandwidth. Downstream bandwidth. All switch ports are full duplex and both sides can send and receive data at the same time. Uplink bandwidth. Reasonable network design and critical nodes recommended to be within 80% of port bandwidth. There are 3 basic principles for design networks: hierarchical, modularized, and standardized. Hierarchical means that the network will be designed into 3 layers: the cron layer, aggregation layer, and the access layer. The design of the 3-layer network creates a clear structure that makes it easy to manage and isolate values in the network. Modularized can isolate network functional areas and restrict possible network attacks and broadcasts in specific areas. It can converge and control routes more easily and enhance the network scalability. Also, it can manage the network and diagnose values more easily. Standardized means that the network should be designed according to the necessary criteria: configuration, IP address assignment, technical protocols, and model selection, which must all be standardized. So design networks can be standard and professional. Based on these 3 principles, we design the network. We can choose to design a 2-layer or 3-layer network. The 2-layer network is divided into a cron layer and access layer. The cron layer is located on the top floor and can be connected to the display and the control devices of the monitoring center. The access layer can access to the front-end, back-end, storage center, server, and other devices. Layer 2 networking eliminates aggregation layer devices, saves cost, reduces fault points, applicable to small and medium-sized projects with less than 500 nodes. However, Layer 2 networks also have some disadvantages. The cron layer has too much traffic pressure, which requires high link resources and is not suitable for large-scale networking. If the 2-layer network cannot meet the requirements, we can design a 3-layer network. And the levels of the 3-layer network are the cron layer, the aggregation layer, and the access layer. With the aggregation layer, Layer 3 network can reduce the traffic pressure on cron layer devices and save link resources. Therefore, it is suitable for large projects with more than 500 nodes. The disadvantage of the 3-layer network is that the operation and maintenance management is too difficult, And the cost is also high because of the complex network structure. After we have learned to chapter 4, we can use these 2 questions to review the content. The first question, what are the 3 principles of web design? The 3 principles are the hierarchical, modularized, and standardized. The second question, please list the advantages and disadvantages of the layer 3 network design. The advantages of the layer 3 network design: reduces traffic pressure on the Chrome layer device, expand capacity easily, and save link resources. The disadvantages are operation and maintenance management is too difficult, and the cost is so high due to the complex network structure. Okay, we have completed network basic, Ethernet switch, IP routing, and network structure parts. Hope this class can help you better understand the network content. Thank you for your watching. We will see you soon.